Hi, welcome back. This is part 2 of States of Consciousness. And now we're going to look at sleeping and dreaming. We'll look at the biological rhythms and sleep. We'll try to answer the question, why do we sleep? We'll look at sleep disorders, and we'll look at dreams and why do we dream. Here you'll find the National Sleep Foundation's Sleep IQ test. The National Sleep Foundation is a nonprofit organization that is dedicated to improving public health and safety by achieving public understanding of sleep and sleep disorders, and by supporting public education, sleep-related research, and advocacy. So this is a nationally representative telephone survey that was administered to 1,014 adults. I'd like for you to take about 5 minutes, pause this presentation, and see if you can answer true or false to each of these questions and keep note of your answers. All right, so by now I'm assuming you paused this presentation. It took about 5 minutes to answer these questions. So let's go through them one by one. Number 1, during sleep, your brain rests. That is false. Although the body rests, the brain remains very active. As our textbook indicates, the brain repairs and reorganizes itself, as well as consolidates memory while we sleep. So certainly, this is not resting. This activity prepares us for alertness and peak functioning during the next day. Number 2, you cannot learn to function normally with 1 or 2 fewer hours of sleep than you need. That is true. Sleep needs seem to be biological. Clearly, children need more sleep than adults. Although most adults need 8 hours to function at their best, our individual needs seem genetically determined. How does one determine one's own unique sleep need? Well, on a night when you're not exhausted, try sleeping until you wake up on your own. If you feel rested, the length of time that you slept provides a fairly accurate measure. Question number 3. Boredom makes you feel sleepy, even if you had enough sleep. Well, this is false. When you feel bored, you may notice that you are sleepy. However, boredom, just like a warm or dark room, does not cause sleepiness, but rather it unmasks it. Number 4. Resting in bed with your eyes closed cannot satisfy your body's need for sleep. This is true. Sleep seems as necessary to good health as food and water because sleep is an active process that does contribute to your health and alertness. Without enough sleep, our body tends to build up what we would call a sleep debt. In other words, you have a sleep bank. If you take out too many withdrawals, your body keeps track of that. So rest is not a substitute for missing sleep. Number 5, snoring is not harmful as long as it doesn't disturb others or wake you up. That's false. Snoring may signal the presence of sleep apnea that can be a life-threatening disorder. Those who suffer from sleep apnea snore loudly and they awaken repeatedly, gasping for breath. Fortunately, there are effective treatments for sleep apnea. Number 6, every person dreams every night. That is true. There is, of course, great variation in how much of our dreams we remember. Number 7, the older you get, the fewer hours of sleep you need. That's false. Sleep needs remain unchanged throughout adulthood. Older people may wake more frequently and they may sleep less, but their sleep need is no less than during young adulthood. Sleep difficulties are not a normal consequence of aging, although they're also not uncommon. Number 8, most people don't know when they are sleepy. That's actually true. Researchers have asked thousands of respondents if they are sleepy, only to be told no just before they fell asleep. Studies suggest that people are not good judges of whether or why they are sleepy. So the lesson here is that when driving, you should not assume that you can tough it out. If you are sleepy enough, you can and will fall asleep any place. So number 9 then, raising the volume of your radio in your car will help you stay awake while driving. Well, hopefully you answered false after listening to the answer to the previous question. The only short-term solution is to pull over and take a short nap or have a caffeinated drink, because caffeine is an antagonist that blocks adenosine, which is a neurotransmitter that helps us to feel sleepy. So the best solution when tired when driving is prevention. Start out only after a good night's sleep. Loud radios fail to keep sleepy drivers alert. Same thing can be said of chewing gum and open windows. These don't work either. Number 10. Sleep disorders are mainly due to worry or psychological problems. That's false. Although stress may be an important reason for occasional insomnia, chronic sleep disorders have diverse causes. For example, sleep apnea is caused by obstruction of the airway during sleep. Narcolepsy, which is marked by daytime sleepiness and sudden sleep attacks, appears to be genetic. No one yet knows the reason for restless leg syndrome, in which the creepy crawly feelings arise in the legs, but they are relieved by momentarily movement. Number 11. The human body never adjusts to night shift work. The answer to this is true. We each have a circadian 24-hour rhythm. This rhythm determines when we feel sleepy and when we feel alert. When we travel across time zones, for example, the light and dark cycles change and our circadian rhythm adjusts. For those working a night shift, the light and dark cycles do not change, so the rhythm does not adjust. Regardless, we are most likely to feel sleepy between midnight and 6 a.m. No matter how long you work a night shift, sleeping during the day always remains a challenge. And finally, number 12, most sleep disorders go away even without treatment. The answer to this is false. Sleep disorders do not disappear without treatment. However, treatment can be behavioral, such as avoiding alcohol before bed, or losing weight for victims of sleep apnea, but treatment can also be pharmaceutical, surgical, or some combination. Allowing a sleep disorder to go untreated worsens the quality of life and can even lead to accident and death. So, how many did you answer correctly? Well, according to that National Sleep Foundation's Sleep IQ test, the average score for adults was only 5.5 correct answers. So clearly our sleep IQ as a nation is lacking. Here's some interesting sleep habits of famous people. Did you know that Leonardo da Vinci slept only 90 minutes a day, and he slept in cat naps of 15 minutes every 4 hours? Salvador Dali, the artist, liked to doze off, sitting up with a spoon in his hand. As he fell asleep, the spoon would fall and clatter to the ground, waking him up, and he reported feeling rejuvenated. This might explain some of his more unusual pieces of art. And finally, former President Clinton thrives on catnaps of 5, 10, 20 minutes at a time, and he can sleep in cars, buses, and is even known to sleep leaning up against the wall. He reports that when he wakes up, he is clear of mind. Now let's look at circadian rhythm. Circadian rhythm is defined as any rhythmic change that continues at close to a 24-hour cycle, but in the absence of 24-hour cues. So this is an internal mechanism that regulates our body. So our daily schedule of waking and sleeping is governed by this biological clock. Our body temperature rises as morning approaches. It peaks during the day. It dips for a time in early afternoon, and then it begins to drop again before we go to sleep. Recent research, for example, indicates that thinking is sharpest and memory most accurate when people are at their peak in circadian arousal. In other words, don't study for your most important exam in the early afternoon after you've had a large meal, when your body temperature starts to drop and you're feeling sleepy. So the body's built-in sleep-wake cycle seems to include a major period of sleep at night, but also a smaller period of sleep in the afternoon. In a study, the volunteers who spent weeks in an underground room isolated from clocks tended to sleep in two periods, one long period at night and the other shorter period of 1 to 2 hours in the afternoon. So these naps began 12 hours after the middle of that main nighttime period of sleep. This is evidence for our body's own circadian rhythm, but what this also suggests is that our body's own circadian rhythm is not exactly the 24 hours dictated by the sun, but slightly longer than that. Our body's clock is governed by two physiological features. One is the suprachiasmatic nucleus, and this is the cluster of neurons in the hypothalamus that governs the timing of the circadian rhythm. The second aspect is melatonin, which is a hormone of the pineal gland that produces sleepiness. An interesting aspect or component of melatonin is how light impacts the secretion of melatonin. So what's happening when light enters the pupil of your eye, that light sends a signal to the suprachiasmatic nucleus, which sends a signal to the pineal gland to stop producing melatonin. So this is one of the reasons why, if you are having difficulty falling asleep at night, your doctor will tell you turn off your electronic devices, especially your computer or your iPhone or smartphone. And the reason why is because most of the wavelengths that come out of electronic devices are heavy in the blue wavelength, the blue light frequencies, and these have a stronger impact on the suprachiasmatic nucleus and the production of the hormone melatonin. And one suggestion that has been offered from doctors is installing an app on your smartphone or your tablet or your computer that limits the blue frequency wavelengths so that the production of melatonin is not impacted. And there is one program, and it's called i.flux, F-L-U-X. Again, it's i.flux.com. You can search that through Google, and it's a free app that is set to your clock's internal device, and it automatically blocks some of the blue wavelengths that are coming in through your eye so that your sleep is not impacted by your late at night electronic behavior. So let's look at sleep a little bit further. First, we need to understand what the electroencephalogram is, and this is also abbreviated as the EEG. The invention of the EEG in the 1920s gave sleep researchers an important tool for measuring the rhythmic electrical activity in the brain. An EEG produces a graphic record of the brain activity while a person sleeps. And it's through the study of the wavelengths that were produced during this EEG experiment that we understand the different cycles and stages of sleep. So in the next section, we'll take a look at that.